In this video, we're going to talk about basic architecture of Kubernetes. Now, Kubernetes is a complete framework which is very powerful, but at the same time very complex. And a lot of people, when they read the documentation of Kubernetes, they actually get overwhelmed because they read the description of how Kubernetes mechanism is built and how all the processes inside of that mechanism actually work to make up the cluster and make it possible to manage and orchestrate the containers. So we're going to look at two types of nodes that Kubernetes operates on. One is master and another one is slave. And we're going to see what is the difference between those and which role each one of them has inside of the cluster. And we're going to go through the basic concepts of how Kubernetes does what it does and how the cluster is self-managed and self-healing and automated, and how you as an operator of the Kubernetes cluster should end up having much less manual effort. And we're going to start with this basic setup of one node with two application pods running on it. So one of the main components of a Kubernetes architecture are its worker servers or nodes. And each node will have multiple application pods with containers running on that node. And the way Kubernetes does it is using three processes that must be installed on every node that are used to schedule and manage those pods. So nodes are the cluster servers that actually do the work. That's why sometimes also called worker nodes. So the first process that needs to run on every node is the container runtime. In my example, I have Docker, but it could be some other technology as well. So because application pods have containers running inside, a container runtime needs to be installed on every node. But the process that actually schedules those pods and the containers then underneath is Kubelet, which is a process of Kubernetes itself, unlike container runtime, that has interface with both container runtime and the machine, the node itself. Because at the end of the day, Kubelet is responsible for taking that configuration and actually running a pod or starting a pod with a container inside, and then assigning resources from that node to that container, like CPU, RAM, and storage resources. So usually Kubernetes cluster is made up of multiple nodes, which also must have container runtime and kubelet services installed. And you can have hundreds of those worker nodes, which will run other pods and containers and replicas of the existing pods, like my app and database pods in this example. And the way that communication between them works is using services, which is sort of a load balancer that basically catches the request directed to the pod or the application, like database, for example, and then forwards it to the respective pod. And the third process that is responsible for forwarding requests from services to pods is actually Proxy, that also must be installed on every node. And Proxy has actually intelligent forwarding logic inside that makes sure that the communication also works in a performant way with low overhead. For example, if an application, my app replica, is making a request to the database, instead of service just randomly forwarding the request to any replica, it will actually forward it to the replica that is running on the same node as the pod that initiated the request. Thus, this way avoiding the network overhead of sending the request to another machine. So to summarize, two Kubernetes processes, Kubelet and Proxy, must be installed on every Kubernetes worker node along with an independent container runtime in order for Kubernetes cluster to function properly. But now the question is, how do you interact with this cluster? Or do you decide on which node a new application pod or database pod should be scheduled? Or if a replica pod dies, what process actually monitors it and then reschedules it or restarts it again? Or when we add another server, how does it join the cluster to become another node and get pods and other components created on it? And the answer is, all of these managing processes are done by master nodes. So master servers or master nodes have completely different processes running inside. And these are 4 processes that run on every master node that control the cluster state and the worker nodes as well. So the first service is API server. So when you as a user want to deploy a new application in a Kubernetes cluster, you interact with the API server using some client. It could be a UI like Kubernetes dashboard, could be a command line tool like Kubelet, or a Kubernetes API. So API server is like a cluster gateway, which gets the initial requests of any updates into the cluster or even the queries from the cluster. And it also acts as a gatekeeper for authentication to make sure that only authenticated and authorized requests get through to the cluster. That means whenever you want to schedule new pods, deploy new applications, create a new service or any other components, you have to talk to the API server on the master node, and the API server then validate your request. And if everything is fine, then it will forward your request to other processes in order to schedule the pod or create this component that you requested. And also, if you want to query the status of your deployment or the cluster health, etc., you make a request to the API server and it gives you the response, which is good for security because you just have one entry point into the cluster. Another master process is a scheduler. So as I mentioned, if you send an API server a request to schedule a new pod, API server, after it validates your request, will actually hand it over to the scheduler in order to start that application pod on one of the worker nodes. And of course, instead of just randomly assigning it to any node, scheduler has this whole intelligent way of deciding on which specific worker node the next pod will be scheduled or next component will be scheduled. So first it will look at your request and see how much resources the application that you want to schedule will need, how much CPU, how much RAM, and then it's going to look at and it's going to go through the worker nodes and see the available resources on each one of them. And if it sees that one node is the least busy or has the most resources available, it will schedule the new pod on that node. An important point here is that scheduler just decides on which node a new pod will be scheduled. The process that actually does the scheduling, that actually starts that pod with a container, is the kubelet. So it gets the request from the scheduler and executes that request on that node. The next component is controller manager, which is another crucial component, because what happens when pods die on any node, there must be a way to detect that the nodes died and then reschedule those pods as soon as possible. So what controller manager does is detect state changes like crashing of pods, for example. So when pods die, controller manager detects that and tries to recover the cluster state as soon as possible. And for that, it makes a request to the scheduler to reschedule those dead pods. And the same cycle happens here, where the scheduler decides based on the resource calculation which worker nodes should restart those pods again, and makes requests to the corresponding kubelets on those worker nodes to actually restart the pods. And finally, the last master process is etcd, which is a key value store of a cluster state. You can think of it as a cluster brain, actually, which means that every change in the cluster, for example, when a new pod gets scheduled, when a pod dies, all of these changes get saved or updated into this key value store of etcd. And the reason why etcd store is a cluster brain is because all of this mechanism with scheduler, controller manager, etc. works because of its data. So for example, how does scheduler know what resources are available on each worker node? Or how does controller manager know that a cluster state changed in some way? For example, pods died, or that kubelet restarted new pods upon the request of a scheduler. Or when you make a query request to API server about the cluster health or for example, your application deployment state. Where does API server get all this state information from? So all of this information is stored in etcd cluster. What is not stored in the etcd key value store is the actual application data. For example, if you have a database application running inside of a cluster, the data will be stored somewhere else, not in the etcd. This is just the cluster state information, which is used for master processes to communicate with the work processes and vice versa. So now you probably already see that master processes are absolutely crucial for the cluster operation. Especially the etcd store, which contains some data, must be reliably stored or replicated. So in practice, Kubernetes cluster is usually made up of multiple masters, where each master node runs its master processes, where of course the API server is load balanced, and the etcd store forms a distributed storage across all the master nodes. So now that we saw what processes run on worker nodes and master nodes, let's actually have a look at a realistic example of a cluster setup. So in a very small cluster, you would probably have 2 master nodes and 3 worker nodes. Also to note here, the hardware resources of master and node servers actually differ. The master processes are more important, but they actually have less load of work, so they need less resources like CPU, RAM, and storage. Whereas the worker nodes do the actual job of running those pods with containers inside, therefore they need more resources. And as your application complexity and its demand of resources increases, you may actually add more master and node servers to your cluster, and thus forming a more powerful and robust cluster to meet your application resource requirements. So in an existing Kubernetes cluster, you can actually add new master or node servers pretty easily. So if you want to add a master server, you just get a new bare server, you install all the master processes on it and add it to the Kubernetes cluster. Same way, if you need 2 worker nodes, you get bare servers, you install all the worker node processes like container runtime, Kubelet, and Proxy on it, and add it to the Kubernetes cluster. That's it. And this way you can infinitely increase the power and resources of your Kubernetes cluster as your application complexity and its resource demand increases. Thanks for watching the video. I hope it was helpful, and if it was, don't forget to like it. This is a video series, so I will create a new one every week. So if you want to be notified whenever a new video comes out, then subscribe to my channel. If you have any questions, if something wasn't clear in the video, please post them in the comment section below and I will try to answer them. So thank you and see you in the next video.